Hello everyone, welcome to another video. Today we'll be solving Cambridge IGCSE Chemistry Paper 6 Alternative to Practical, October-November 2021, 062061. Question number 1. The table gives the boiling point of 4 alcohols. We can see butanol with 117, then ethanol with 79, pentanol with 138, and propanol with 97 degrees Celsius as boiling point. The apparatus shown can be used to obtain propanol from a mixture containing butanol, ethanol, pentanol, and propanol. Now we can see apparatus A, which is thermometer, apparatus B, which is a condenser. Alright, name the items of apparatus labeled A and B. So A is a thermometer and B is Liebig condenser. Part B. Name this method of separation. So we can see that there is a fractionating column that is present. So we can call it fractional distillation. Part C. Explain why it is safer to heat the mixture of alcohol in the way shown rather than with a Bunsen burner. We know that alcohols are highly flammable. So heating them directly with a Bunsen burner would be very risky as it may catch fire. Part D. Describe how propanol can be obtained from a mixture using data from the table. So first of all, what we'll have to do is that propanol has a boiling point of 97 degrees Celsius if we notice, and ethanol has a boiling point of 79 degrees Celsius. So first of all, we will boil off the ethanol, and then we are going to get propanol. Part E. Explain why the apparatus in the diagram cannot be used to obtain butanol from the mixture. If we notice butanol has a boiling point which is greater than 100 degrees Celsius. So boiling point greater than 100 C. We are using a water bath. A water bath cannot exceed 100 C temperature. Part 2. A student investigated the mass of lead iodide precipitate formed when aqueous potassium iodide reacts with aqueous lead nitrate. So we can see the equation. Potassium iodide aqueous reacting with lead nitrate aqueous. It is forming lead iodide solid, and we are getting potassium nitrate aqueous. The student did 7 experiments. Experiment number 1. Using a 50 cm3 measuring cylinder, 25 cm3 of aqueous potassium iodide was poured into a beaker. So we are using a measuring cylinder to measure 25 cm3 of aqueous potassium iodide. Now we already know one thing: measuring cylinders can be used really quickly. However, they are not a good way of measuring a fixed volume of any reagent. In this case, like 25 cm3, they are not good at doing it because they are really inaccurate. However, using a clean 50 cm3 measuring cylinder, 10 cm3 of lead 2 nitrate was added to the aqueous potassium iodide in the beaker. The solution were mixed together. The mass of the precipitate of lead 2 iodide formed was found. The experiment 2 was repeated. The experiment 1 was repeated using a larger volume of lead 2 nitrate than in experiment 1. Then again, the experiment 1 was repeated using a larger volume of lead 2 nitrate than in experiment 2. And the process went on and on until experiment 6. Part A. Using the measuring cylinder diagrams to complete the table. Volume of aqueous potassium iodide that we used. In every experiment we used 25 cm3. So there is nothing to record there. Volume of aqueous lead 2 nitrate Alright, so the volume of aqueous lead to nitrate that we added should be calculated from here. So we can see this is 15, so 16. We can see the volume is 23. The volume is 29. We'll have to read in this direction. So volume is 39. Then we can see 44. And we can see 48. We can see that after the addition of 39 cm cube of lead to nitrate, there was no further precipitation after that. So after 39 cm cube, we can definitely say that the volume of potassium iodide was the limiting factor. Plot the results from experiment 1 to 7 on the grid. Draw two straight lines through the points. Extend your straight lines so that they meet. The question says in the part C, from your graph, deduce the mass of lead to iodide precipitate that would be formed if the experiment 1 was repeated using 20 cm cube of lead to nitrate. Show clearly on the grid how you have worked out your answer. So for 20 cm cube of lead to nitrate, we will extrapolate. So approximately we are going to get 2.5, 6, 7, 8, 8.5. Part D. Explain why the same mass of precipitate is formed in experiment 5, experiment 6 and experiment 7. So basically we can already conclude that in experiment 5 and experiment 6 and in experiment 7, in these three experiments, our lead to nitrate was in excess and our potassium iodide was the limiting reagent. Part E. Sketch on the grid the graph you would expect if all the experiments were repeated using aqueous potassium iodide with half the concentration. So whenever these kind of reactions are done with half the concentration, we have to understand first of all, the maximum amount of precipitate that we are going to get is going to be half of that original one, and then we are going to get precipitate until half the volume. So 5.1 divided by 2, the answer will be 2.55. So 2.55. Part F1. State why using a 25 cm cube pipette to measure the volume of aqueous potassium iodide would be an improvement. So if we look into this particular experiment, we were measuring the 25 cm cube of aqueous potassium iodide with measuring cylinder. You know, as I have already told you, using a measuring cylinder is a little bit inaccurate. So using a pipette would be more precise than measuring cylinder. Part 2. State why a 25 cm cube pipette could not be used to measure the volume of aqueous lead to nitrate in each experiment. Because we were using a variable quantity of lead to nitrate, and for that reason we cannot use a pipette, because pipette measures only a fixed volume of 25 cm cube. Part G. Describe how the solid lead to iodide can be separated from the reaction mixture and its mass be found. So we can basically filter the solid lead to iodide. We can filter the solid lead to iodide using a filter paper, and then what we can do is we can wash that residue to get rid of any impurities. Then we can dry it inside the oven, and then we can weigh the mass of lead to iodide. Question number 3. Solid Y and solid Z were analyzed. Tests were done on each solid. Test on solid Y. Solid Y was dissolved in distilled water to form solution Y. Solution Y was divided into 4 portions in boiling tubes. 4 boiling tubes. Okay, first of all, test 1. Aqueous ammonia was added dropwise and then in excess to the first portion of solution Y. A white precipitate formed which was insoluble in excess. So a white precipitate forms, and if it is insoluble in excess is usually it is in indication of aluminium, because calcium wouldn't precipitate with ammonia, so it is aluminium. Aqueous sodium hydroxide was added dropwise and then in excess to the second portion of solution Y. A white precipitate formed which dissolved in excess to form colorless solution. So we know that on addition of sodium hydroxide, aluminium ion and calcium ion forms white precipitate. Now, when excess sodium hydroxide is added, calcium doesn't dissolve. So this will be eliminated. So aluminium is the answer. Next, a piece of aluminium foil was added to the solution formed in test 2. The mixture was warmed and any gas given off was tested. We must understand that sodium hydroxide followed by aluminium foil is usually a test for presence of nitrate. So we are testing for presence of nitrate. If nitrate is present, then a gas will be given off, which is ammonia. Ammonia gas will be given off, and the ammonia gas will basically turn damp red litmus paper blue. So we can see nitrate present. Test 4. About 1 cm³ of dilute nitric acid and a few drops of aqueous silver nitrate were added to the third portion of solution Y. So 1 cm³ of dilute nitric acid with a few drops of silver nitrate. Nitric acid followed by silver nitrate is definitely a test for halide. So if there is any halide ion present, it will be detected. The solution remained colorless, no precipitate formed. So we can definitely say no halide present. Name the gas given off in test 3. So since they asked us the name, we must write the name. So ammonia. Identify the solid Y. Well, this particular solid tested positive for aluminium ion and for nitrate. So we can name it aluminium nitrate. Part C. A strip of universal indicator was dipped into the fourth portion of solution Y. The indicator paper turned orange. What additional information does this give about solution Y? Since the indicator paper has turned orange, universal indicator paper turns orange when there is a presence of weak acid. So orange indicates weak acid. So we can say that this particular solution is weakly acidic. The word weakly is in bracket because you may or may not write it, and it's fine. Test on solid Z. Solid Z is iron 2 sulfate. Complete the expected observation. Solid Z was dissolved in water to produce solution Z. Solution Z was split into 3 equal portions in 3 boiling tubes. Aqueous ammonia was added dropwise and then in excess to the first portion of solution Z. Observation. Now we know that iron Fe2+, when it reacts with ammonia, it produces green precipitate. and that green precipitate does not dissolve in excess ammonia. Part E. About 2 cm cube of dilute hydrochloric acid was added to the second portion of solution Z. Observation. Adding acid to iron 2 sulfate would not give any change because it's a salt, it's a neutral salt, and the acid would not react with that particular salt, so no change. Part F. The solution from E was warmed and a pipette of filter paper soaked in acidified aqueous potassium permanganate was held at the mouth of the boiling tube. Observation. So addition of an acid such as HCl followed by heat, all right, is basically a classic test for sulfite, SO3 minus ion. However, we know that it's iron sulfate, which is SO4 minus, and thereby would not test positive. So we will see no change. Part G. About 1 cm cube of dilute nitric acid followed by a few drops of aqueous barium nitrate were added to the third portion of solution Z. Alright, so nitric acid followed by barium nitrate is a test for sulfate. And since this particular reagent already contains sulfate, so it's going to test positive. So the observation is going to be white precipitate. Question number 4. A mixture contains 3 solid compounds: copper 2 sulfate, cetyl alcohol, silicon dioxide. The table gives some information on the solubility of these 3 solids. Name of compound: copper 2 sulfate. Solubility in water: soluble. Solubility in propanol: insoluble. Cetyl alcohol: solubility in water: insoluble. However, it dissolves in propanol. Silicon dioxide is insoluble in both. The question says plan a method to obtain a pure sample of each of the 3 solids, copper 2 sulfate, cetyl alcohol, and silicon dioxide from the mixture. You have access to normal laboratory apparatus. So, as we can see, the cetyl alcohol is insoluble in water. However, the copper 2 sulfate is soluble in water. So we can first dissolve all of this in water, and only filtrate we will collect will be copper sulfate solution. And cetyl alcohol and silicon dioxide will be remain as a residue. And then that residue we can dry off that residue, and then basically we can use that particular residue and dissolve it in propanol. In that way, the cetyl alcohol will dissolve in propanol, and the residue that we are going to collect is going to be silicon dioxide. And if we evaporate the solution of copper 2 sulfate, we're going to get copper 2 sulfate. If we evaporate the solution of cetyl alcohol in propanol, we're going to get cetyl alcohol. And silicon dioxide is obtained already in the form of residue, so we just need to dry it. So I'm writing the procedure for you. And guys, thank you for watching the video. See you in the next video. Please like, comment on the video. If you want to watch videos like this, let us know. All right. And if you have any question paper in your mind which you want us to solve, just post it, all right, in the comments, and definitely I will try and answer it for you. Thank you for watching the video. Bye bye.